So for Unit 9, we're going to be talking about radicals. And radicals are basically square roots, but we can also have cube roots and fourth roots and stuff like that. And so it helps us to kind of understand some vocabulary. So the first thing is that you need to understand that this is the radical sign. The radical sign is what we usually call the square root sign. And what's underneath it is called the radicand. So whatever's underneath there is called the radicand. And whenever we take the square root of any number, there's always technically two square roots, okay? So if I were to take the square root of 25, the square root of 25 is positive 5, and it is negative 5. The positive 5 is what we call the principal square root. And I think that's easy to remember because the principal is positive. They both start with the P's. So, it says here the principal square root for any number a and non-negative number b. Whenever you have the square root of a squared, it's just a. And when you have the square root of b squared, it is just b. So remember this, and it's important to note that the square root and the square are opposites. They are opposites, so they always cancel each other out. Just like adding 4 and subtracting 4 is going to cancel, and multiplying by 4 and dividing by 4 is going to cancel, taking the square root and the square is going to cancel. So it asked me for the square root of 49. Well, that would be 7 and negative 7. But when I take the square root of 7 squared, that squared and that 2 are going to cancel each other out, and I'm just left with 7. For the square root of 2.1 squared, again, the square root and the square are going to cancel, and I'm left with 2.1. The square root of 0 is just 0, because 0 times 0 is 0. So what's really cool about radicals is that I can multiply them together. So if I had two non-negative numbers, it's important to note they are non-negative, a and b. The square root of a times b is the same thing as the square root of a times b. I can put them underneath one square root symbol. So this means I can go ahead, when I have the square root of 2 times the square root of 8, I can go ahead and multiply that and rewrite it as the square root of 2 times 8 under one square root symbol. Well, 2 times 8 is 16, and the square root of 16 is positive 4 and negative 4. So a problem that looked really complicated to begin with actually turned out to be kind of easy because it gave us two simple numbers. Then I have the square root of 3 times square root of 7. Well, I can rewrite that as the square root of 3 times 7, which is the square root of 21. I cannot take the square root of 21, so I'm just going to leave my answer as the square root of 21. Now, sometimes when we do this, we're going to get radicals that we can do what we call simplify. So we can't actually take the square root of them. For example, 45. 45 does not have a square root. It's a decimal. It's going to be like 6.7. But I can factor out some perfect squares out of 45. And the way I do that is I'm going to take 45 and I'm going to prime factor it. Well, 45, that's 5 times 9. And 9 is 3 times 3. So instead of the square root of 45, I can say it's the square root of 5 times 3 times 3. And I look for pairs of numbers. So I have a pair of 3s. And if there's a pair of 3s, what I can do is I can bring that pair out and basically take the square root of it. So I'm just left with one of them, square root of 5. Now, the reason that this works is because when I write 45, the first thing I wrote out is that it was 5 times 9. So the same logic applies that if I can multiply two square roots together and make it 1, then I can take one square root and split it into 2. So instead of the square root of 9 times 5, I can say it's the square root of 9 times the square root of 5. Well, the square root of 9 is 3, so I end up with 3 square root of 5. Notice either way I did it, I got the same answer. The same thing is true when I divide, that if I have I have the square root of a divided by the square root of b, I can write that as 1 square root of a divided by b. So if I have the square root of 30 divided by the square root of 6, I can write that as the square root of 30 over 6. And 30 divided by 6 is 5, so I end up with the square root of 5. I have square root of 48 divided by the square root of 3. I can write that as the square root of 48 over 3. 48 divided by 3 is 16. I can find the square root of 16. It's 4 and negative 4. I can also do the opposite, that if I have the square root of, say, square root of 10 over 9, I can actually split it into two parts, square root of 10 over square root of 9. And sometimes that helps because I can actually take the square root of one of those pieces. I can't take the square root of 10, but I can take the square root of 9. And the square root of 9 is 3. So I end up with square root of 10 over 3. So I can split the radical into a quotient, which means I'm dividing, of the two radicals and simplify the numerator and the denominator. So when I start having to simplify two radicals that are fractions, the first thing I want to do is I want to try and combine them into one. And then I'm going to have to go from there and see what happens. So I have the square root of 3 over 8 times the square root of 5 over 6. Well, my first rule said I could combine that into one, square root of 3 over 8 times square root of 5 over 6. And I can start multiplying. When I multiply fractions, I multiply tops. 3 times 5, which is 15. I multiply bottoms. 8 times 6 is 48. And then I want to see if I can reduce. Okay, so I've got to see if I can reduce this. Well, 15 and 48, I can divide both those by 3. 15 divided by 3 is 5. 48 divided by 3 is 16. And then I'm thinking, can I take the square root of either of those? Well, I can't take the square root of 5, but I can take the square root of 16, and it is 4. So now how I got from here to here, just to make sure you know, is I said square root of 5, and I said I'm going to separate it, so square root of 16, and the square root of 16 is 4. For my last one, I have square root of 15 over 7 times square root of 21 over 20. So I'm going to put it as 1, so 15 over 7 times 21 over 20, and I'm going to multiply. 15 times 21 is going to give me 315. 7 over 20 is going to give me 7 times 20 is going to give me 140. And then I've got to see if I can simplify. Well, I know they're both divisible by 5, so I can always start there. 315 divided by 5 is going to give me 63. I get 28. And then I'm looking at 63 and 28, and I know I can divide both those by 7. So 63 divided by 7 is 9. 28 divided by 7 is 4. Now, what you can do in your calculator is you can type in 315 divided by 140, and it's going to give you some decimal, some blah, 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 blah number. And you can do math, enter, and it will convert it back into a fraction for you, and it's going to give you this square root of 9 over 4. Well, now I'm looking at each piece and I'm thinking, can I take the square root of either of those? So I'm going to split it. Square root of 9 over square root of 4. Well, the square root of 9, that's 3. Square root of 4 is 2. So my final answer ends up being 3 over 2. All right, so for 1 through 5, I'm supposed to simplify the product. So I have square root of 7 times square root of 12. So I'm going to go ahead and write it as the square root of 7 times 12. And 7 times 12 is 84. So I'm going to prime factor 84. So that means I'm going to split it down. Well, I know 84, I just figured out was 7 times 12. 12 is 6 times 2, and 6 is 2 times 3. So my square root of 84 is really the square root. I'm going to write these end numbers in order. 2 times 2 times 3 times 7. I'm looking for pairs. I have a pair of 2, so that means I can bring one out. I can't pair 3 and 7 with anything, so I'm going to go ahead and multiply 3 times 7, and I get 21. So the simplified form of square root of 7 times square root of 12 is 2 square root of 21. Number 3, I have square root of 33 times square root of 3. So I'm going to multiply that together. Square root of 33 times 3 is square root of 99. And then I'm going to prime factor 99. Well, I just learned that it was 3 times 33. 33 is 3 times 11. So I have the square root of 3 times 3 times 11. I'm looking for pairs. And once I find a pair, I can bring that out. So I have 3 square root of 11 as my simplified form. For number 5, I have the square root of 5 times the square root of 11 times the square root of 8. I can multiply all of those together, and I'm going to get, so square root of 5 times 11 times 8 is going to give me the square root of 440. So now we're going to have to prime factor 440, which isn't as bad as you're thinking it's going to be. So 440, well, it's even, so now I can divide it by 2, and I get 220, which I know is even, so I'm going to divide it by 2, and I get 110. And I know that's even, so I'm going to get 2 and 55, and 55 is 5 and 11. So I can write this as the square root of 2 times 2 times 2 times 5 times 11. And again, I'm looking for pairs. We'll have a pair of 2's, which means I can bring a 2 out. I don't have any other pairs, so I'm going to go ahead and multiply 2 times 5 times 11. Well, 2 times 5 is 10, times 11 is 110. So that would be my final answer. All right, so number 7, I'm supposed to simplify this. Well, right now it's currently underneath it's under 2 square root symbols, so I'm going to rewrite it as the square root of 48 over 12. And I want to see if I can reduce that. Well, I know I can actually divide 48 and 12 by 4. By 12, 48 divided by 12 is 4. 12 divided by 12 is 1. So I end up with the square root of 4 over 1. And 4 over 1 is just 4. Well, the square root of 4 is 2. So that was my final answer. Number 9. I have the square root of 38 over the square root of 19. So I'm going to combine that into one square root, which is 38 over 19. And I can actually divide 38 by 19. And when I do that, I get 2. So I have to decide, can I take the square root of 2? And I cannot. It does not exist. So square root of 2 is my answer.